everyone, it's Sorkin. Today we have a problem when we are given an input array, for example this one, and we need to find the subarray with the largest sum. Let's say that in this case it's this subarray 4, minus 1, 2 and 1, which is with the largest sum 6. There are several ways how we can solve this problem, but the most efficient way is to use Kadane's algorithm. And let's see what's the idea behind Kadane's algorithm. So for that, let's maintain 3 variables that we are going to use. First one is the previous max, right? Previous max value, and the current max value, current max. Also, let's maintain, and then another one is the total max that we are going to return, total max. So let's start first with this element, with the first element, right? So we are going to, our previous max, we are going to set to -2, and the total max we are going to also set to -2. And we are going to start from the first element. So for the first element, at each step, we are making a decision. We are taking the previous max, right? Plus, let's say that it's our input array, input, right? Plus input I, right? Plus input I, or input I. And we are taking that as our current max. So for example, let's check this example. So our previous max is -2, right? Our previous max is -2 plus 1, and our input is, so we are at the first index, right? We are here. So first one is equals to 1. So our current max is equals to, we are taking the maximum of the previous max. So kind of dynamic programming. So sum of the previous max plus our input. So up to this point, right? Or our input. And we are updating our current max to 1. How about the total max? So for the total max, we are taking either whatever total max we had earlier, or the total max or the current max. The current max is more than our total max, so we are updating that to 1, okay? And our previous max, about the previous max. The previous max is, we are setting that the current max, it becomes 1. So that's the idea behind the Kadane's algorithm. As we progress, right? As we progress further, let's say that we are at this point. So we are considering, let's say, this index. As we are considering this index, so we have already calculated that whatever the maximum that we have until this point, at the next point, for the next element, we can either add that to our previous max, and or let's say that this value is, let's say that, I don't know, 19 or something, right? And this is the already, and this value up to here, previous max, is, let's say, negative. And all these numbers have been negative, but since our input is like 19 or 20 or something, then we are taking our input, then we are taking this one as a max element. And as we go here, let's say at the last element, right? As we are at the last element, we are again running the same algorithm. And by the time we reach the end of our array, we have the total max set to our total max value. Okay, first thing that we are going to do, let's just create our previous max, which is our first element, right? At the 0 index. And and also let's, our total max, also set that to nums 0, right? And now we can start to go over our array. For that, we are going to start with the int equals to 1, right? I is less than our nums length, and we are incrementing I. So what we are checking? We are checking that let's create here current max. Our current max is, so we are taking the maximum of previous max plus whatever the value we have at the moment, I, or the value itself, right? Maybe this value is more than previous max plus our current value, so I, right? And now we are checking that for our total max, we are updating that if this our current max, if our current max is more than our total max, then we are updating our total max. Okay, and also our now previous max. Now we're going to go to the next element. Previous max we are setting to our current max, whatever the current max is. And at the end, we are returning our total max. Okay, let's run it. Okay, great, it works as expected. Let's calculate time and space complexity. What's the time complexity of this solution? The time complexity is, since we are running, going over our array only once, it's n, and we are not using any space, so it's constant. Okay, hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time, bye.